Hello and welcome. This presentation is an introduction to the Rubin Science Platform, which is currently in development by Rubin Observatory and will in the future provide resources for scientists to access and analyze the data products from the Legacy Survey of Space and Time, the LSST. The VRC Rubin Observatory is being built on Cerro Pachon in Chile, the same mountain which hosts the Gemini South and SOAR observatories. The Rubin Observatory will house a Simonier survey telescope, which has an 8.4 meter primary mirror. The LSST science camera has a 9.6 square degree field of view and 6 optical to near infrared filters, UG, RI, Z, and Y. Once construction and commissioning are complete, the Rubin Observatory will execute the 10-year Legacy Survey of Space and Time, the LSST. The LSST will be an optical imaging survey of the southern sky starting in a few years. Both the observatory and the survey are designed to make major advances in 4 core science areas: dark matter and dark energy, the solar system, transients and variable stars, and the Milky Way and local volume. The LSST will cover about 1/3 of the sky each night and in total detect billions of stars and galaxies and millions of transients, variables, and moving objects. The scope and potential for science with the Rubin Observatory's LSST is as enormous as the unprecedented volume and complexity of the LSST data products, and the technology and methodologies are correspondingly evolving to meet this challenge. It will not be possible for individuals to download the entire LSST dataset to their local computer. Instead of bringing the data to themselves, scientists will need to be able to bring their analysis to the data. The venue for this is the Rubin Science Platform, or RSP. The RSP is a set of integrated web-based applications and services running at the Rubin Observatory Data Access Centers, or DACs. The RSP will include tools to query, visualize, subset, and analyze the massive LSST data archives in a stable software environment located next to the data. Please see the other videos in this series created for the AAS 2021 winter meeting for more information about the data products themselves, as we will not cover them in this presentation. The Rubin Science Platform is currently in development, but you can find a high-level overview of the plans for the RSP in its vision document at ls.st/lse-319. The key points of this document are summarized in the rest of this talk. The Rubin Science Platform is composed of 3 aspects: the portal aspect, the notebook aspect, and the Applications Programming Interface, or API aspect. All 3 aspects will be available to users, and all 3 will be able to access all of the LSST data products. The 3 aspects are just 3 different ways for users to interact with the LSST data. The next 3 slides cover each in turn. The portal aspect is like a window into the LSST data. Shown here at left is an example of how data catalogs can be accessed, subsetted, and visualized with the Firefly framework in the portal. With the portal aspect, users can explore and analyze the image and catalog datasets, view and interact with LSST images, subset the data catalogs via form submission or query languages, and plot the scientific graphs. The notebook aspect provides a venue for users to perform next to the data analysis of the LSST data products. Shown here at left is an example of a Jupyter notebook where the user writes code and interacts with outputs, such as plots. To the right of that is an example of subsetting the data in a globular cluster using the bouquet package's lasso function. The notebook aspect provides environments with pre-installed libraries, for example, the LSST Science Pipelines or Anaconda, and also allows users to install their own packages and tools. The Application Programming Interface, or API aspect, provides remote access to the LSST data that enables integration with external tools. The API aspect will use widely adopted community-accepted formats and protocols, such as those defined by the International Virtual Observatory Alliance. Some users might be familiar with, for example, the Table Access or Simple Image Access protocols, or TopCat, the tool for operations on catalogs and tables. As a final note, the RSP also includes cross-aspect functionality. For example, the portal aspect's catalog browser and the notebook aspect's data visualization capabilities can be used in tandem. The Rubin Observatory will provide a variety of user resources related to the Rubin Science Platform. Database services enable the catalogs to be queried in common languages, such as the Astronomical Data Query Language, ADQL. Although, as previously mentioned, it will not be possible to download all of the LSST data, relatively small subsets of the catalogs can certainly be downloaded by users for local processing with custom software. The RSP's file services will provide disk space for users to save, for example, uploaded code, derived data products, and their documentation. Compute services will provide processing resources for jobs launched via the notebook or the API aspects. 10% of the Rubin Observatory's total computing resources will be available for users. Within the RSP, users will be able to define working groups with other users within which software and derived data products can be shared among all three aspects. Rubin Observatory will also provide support for science and use of the RSP, such as tutorials, workshops, and an open community forum for bug reports, help requests, sharing solutions, and collaboration. A users committee will represent the science community to the Rubin Observatory Director's Office and be charged with advocating for RSP developments on behalf of users, such as upgrades or additions to the analysis tools to enable science. Access to RSP requires data rights, as defined in the Rubin Observatory data policy. All astronomers working in the US and Chile have Rubin Observatory data rights, including students, as do named individuals on international contributor teams. If you have any further questions about Rubin Observatory, there are a variety of ways to find answers. First, please come back to the VRC Rubin Observatory booth at the NSF Pavilion in the exhibit hall of the 2021 Winter AAS meeting, where we would be happy to answer your questions. Second, please feel welcome to visit our online community forum at community.lsst.org. This is the best place to seek answers for questions about the LSST. The contents of our forum are publicly available to search and read, and anyone may obtain an account in order to post questions or participate in discussions. Third, consider joining one of the 8 LSST science collaborations. The science collaborations are independent worldwide communities of scientists, self-organized into collaborations based on research interests and expertise. They are laying the groundwork necessary to prepare for doing science with the LSST data products and services and are open and welcoming to all, especially to students. Joining a science collaboration is a great way to learn about Rubin Observatory. Goodbye and thanks for watching.